So let's have some fun talking about some ARM64 stuff. In this video, we're not really going to focus on the malware itself, this being an updated Banshee stealer. It's like a new variant. I think it was last week when this was first talked about. But what this sample does that's interesting is it checks for launch arguments and it actually does a string comparison against one of the expected launch arguments that are passed in this binary. So we're going to focus on that because it's pretty interesting and it allows us to dig into some cool ARM64 related instructions. Okay, so here in Binja, we're at the start function, so the main function in this case, and all the way at the top, we see this if statement for this value here, which I renamed to argc. This would be arg1 or arg2 when you open this binary up in Binja, but I renamed that to argc since this is a C++, or Objective-C binary. And usually when you write this, you have like your int main function, and then you have the first argument would be argc, and then the second argument would be a car pointer to argv, which is an array of arguments. So that's what this would look like, passing into this start function. And there's a check to see if the value in argc is greater than 2. And if it is, then this happens. So what this does is, since we have this renamed to argv, this pointer to the argument array, we have an offset so of 8. So adding 8 to the start of this array, the first element of the array would be the address of the array itself. So if you're adding 8, which is the length of a pointer, to that address, then it's going to be looking at the second element in that array. And that would be argv1, which would be the first launch argument that's passed to this binary. And it's dereferencing that. We can see this star here, dereferencing that string. It's passing in that string as the first argument to the stir comp, so stir string compare function, and it is loading in this run controller string that's passed into this second argument, and this is going to return if these strings match. If this return value is 0, that means that they do match, and that would be returned here. And we can then see this argc and the return value of the string copy are then checked. And if it's 0, and if the argc count or the arg count is greater than 2, then you do this. All right, so this is what we're going to focus on from a disassembly perspective because it's cool to look at this and see how this works. So let's get started. I'm going to just kind of move this over so we can focus on the ARM64 details. Okay, so this is going to be our function prologue at the start of main, or this start function here in Binja. And this is going to just prepare the stack for local variables. We're not too worried about that. The first instruction that we do care about is this right here. X1 is being moved into X20. X1 is going to be argv. So this is argv. X0 is going to be the arg count, so argc. So X20, X21. These are instructions related to the stack check guard and the arc for memory management in Objective-C. So we're not worried about these instructions. The one that we are worried about is this one. This is a comparison instruction for the value that's in W21. So W21 is the 32-bit equivalent of the X21 register. This contains that count of arguments that was passed in, that was moved in from X0. So it doesn't need all 64 bits here, so it just uses 32 bits to reference that value. And that is going to be the argc, and that's compared against the value of 0x2. So compare does a subtraction, and that subtraction then sets flags that are used by conditional branch instructions, which is what we see next. So this subtraction will look something like argc minus 0x2. So that's going to set flags. And this branch will go to this address if this is what that .lt mean, less than. So if W21 is less than 2, then we go to this address and start execution from there. If there are more than 2 arguments in this arg array, then we continue here. So what this does is we have this value in x20 that's the argv that was moved in from x1. This is going to add 8, right, to the start of the memory address of x20. X20 itself would be argv0, so that's going to be pointing to the first element. If you add 0x8 to that, that is moving pointer length from the start of this, which will be the next argument. So that would be argv1. That is loaded into x0. That's a pointer that's then loaded into x0. And then we have these pair of instructions that one, this ADRP gets a page, a pointer to this page. And you can see if we hover over this, that's actually at the start of this is the OSA script for this, which we're not going to be covering, but it's just interesting to see. That pointer gets moved into x1, then there's a calculation with that pointer for this value of E67 to add to that address, and that's moved into, or that's saved into x1, and then there's a string comparison. So the string compare, which is what we covered in the decompilation, is going to use that string to compare against the dereferencing of the actual argument that was passed in, this launch arg. So another way of looking at this is using this chart. We just went over this, but I think it's interesting to kind of see this. So usually when you write in C, C++, or Objective-C, you have this int main. So x0 is going to be that first argument. This array of arguments is in x1. If we look at this from the disassembly perspective we just did, right, we see that move, those two move instructions, right? So the reason that this happens a lot in ARM is because x0 and x1 are overwritten often, especially x0, since that's the return value of functions. That's where that's stored. So in order to preserve whatever it is that's in x0, it gets moved into another register. That in this case is argc, and then it's compared, right? That subtraction that we talked about. Then if it's less than, it goes here. If not, and this happens, it gets the dereferencing that address of x20 plus 0x8, and we can see that that ends up being argv1. And then there's a string comparison that happens after that. Okay, so I think this is interesting to look at from a debugging perspective. So I'm gonna sign in to my VM and let's debug this for fun. Okay, so I'm loading up LLDB and I'm passing in this binary and I'm passing in 2 args here. So let's do that. I'm just gonna do this to stop at entry. So we're gonna launch this process and then stop at the entry. Okay, and then let me get this address of start, or the main function. So create a breakpoint, 0x1, 0, 0, 0, 0, 6, 7, 0. Okay, so C to continue. All right, so this is what we already reviewed when we were looking at the disassembly in Binary Ninja, but just gonna kind of walk through this and look at those values as they're stored. So right at the start of all this, before anything happens, those values that we talked about, that argc and that pointer to the array of arguments, are already in those registers. So you can kind of look at those. We know that there's going to be a count of 3 arguments because we have the binary itself. And then I passed in test and args. So if you just look at that really quickly, we'll see that that's the count of 3 in x0. And if we look at x1, this is going to be a pointer to this arg array. So if we look at that here, let me just copy this over. So this is going to be the first argument, second argument, third argument. This is argv0, which is going to be the path of the binary itself, which will be this Banshee. This was from last week, so 0903. All right, so if we look at that, we can actually see that. It's cool to just view these values here. So there goes my path to this and how it was executed. And then we have, after that, we have this, which will be the first launch argument. So X, and that will be test, which matches what we saw up here. Right, so test, and we see that that's null terminated. We see those zeros here. Okay, so the next thing would be the args argument that was passed in. And that is args, and that's also null terminated. So if we just kind of go through this, we'll see the same thing we saw in Binary Ninja, but just to show how that works. So this is all the function prologue. We don't care. These are moving those two values, the argc and the argv, into different registers. Boom. So we look at that 20 and x21. Right, we have the argc, and then we have that pointer to the arg array. This is going to be related to the stack and the arc memory management stuff that we don't care about. We have this comparison. We're going to compare the value in W21, which we can also look at the W equivalent here by just using W21. It has that value of 3. It's going to do a subtraction of that. It's going to set flags, and then if it's less than, it's going to go here. It's not going to be less than, so we're going to continue at this address. We just press next. Next. See, we did not go here because it's not less than. Now this is going to be that calculation for that second element inside of this arg array, which ends up being the first launch argument to this binary. That's going to be x20 plus 0x8. And if you look at that, which I think is pretty cool. So plus 8. So this is going to be that first element that we talked about. Here's the address, but of course we're looking at this in, due to its Indianness, we're looking at this backwards. So it's 1, 6F, DF, F8, F0. But if we count from index 0, 1, 2, 3, 4, 5, 6, 7, 8, we'll start here. Right, so that's going to be that calculation that then gives this address that's ending in F913. We can also see this here. This shows up, right? Yeah, so each one of these are bytes, and then if you go 8 bytes, you'll get to this over here at the start of this. So this is going to be what's loaded into X0, this pointer. We can see that if we look at X0 now, this is what's in X0. If we click next on this instruction, which executes this, we're going to have this pointer, it's moved into X0. Right, so ending in F913. If we look at that, that is test, right? It's null terminated. All right, so then the next thing that happens for this string comparison instruction, we have this ADRP, which is going to get that page. What's interesting about that page is we saw in Binary Ninja, that's going to actually be the address of the OSA script. So if we look at that, we'll see all of that OSA script here before it calculates this offset. So next, if we read X1, yeah, so that goes all of that. We're not too worried about that because it's just going to use this address and make this calculation here. Okay, so then next, if we reference that again, we'll see it's referencing this address, which is pointing to the string, and then it's going to do the string comparison. So this is not going to return 0 because the value that's stored in X0 is not going to match, right? So test is not going to match run controller. So the return value after this function is called, this is going to end up not going to this address, because this is a check to see if this is 0, and it's not going to be 0 since they don't match. But we can still kind of play around with this. So 2, so it's not 0. So when it does this compare if 0 inside of W0, it's not going to match. So then it's going to continue. It's not going to go to this address. All right. So what happens when it does match? Just to kind of cap this up, because I think it's interesting to go over that. We are here because the string comparison, if it does have this run controller, this ends up being 0. This argc is 2 as long, or it's more than 2 or 2 if there's a launch argument that's passed. And what ends up being done here is another dereferencing of the argv array plus 0x10. So 0x10 is 16 bytes, because of course we're talking about hex here. So if we kind of look at this, 0x10, that's 16 bytes. That's going to get the next element, so that's argv2. That's then going to be dereferenced, and it's going to be passed in as the argument to this string with UTF string using the NSString class, and it's going to set this here after you get the return value for arg. And what that's going to do is this is going to be argv2 string. And then this ends up being passed into this initializer with the encrypted key here, which we can see if we go over. That's going to be passed into this controller class that was allocated, and it's going to run this system init with encryption key. And then this is going to end up running this controller.manage method. And if we go to controller.manage, just to show this, we'll see all the stuff related to this stealer. So checking to see anti-VM stuff and getting the password, collecting data. Luckily, all these symbols are still here, so it's easy to see what happens. But again, the focus was not on that. The focus was more for this video on understanding how this works from an ARM perspective, being able to look at launch arguments, seeing the calculations, being able to debug that. And yeah, so making sense of these launch arguments, since this does happen in malware samples, especially for stage 2. All right, well, that's it for this video. Thanks.